All right, I just discovered a problem with my document, with my code. All right, so when I wrote up all this code, I was working and I just had all the code straight out. I didn't have it in an R Markdown file. And what I did was I copied and pasted all of the code into R Markdown, and then I started making the document. So when I ran the R Markdown, when I ran the code straight out, it successfully removed stop words. Now I'm looking here and I see the, and, you, with, that, who, for, all, from. These are all stop words. These are clearly uninformative words. There is no information in here. Now fight is something that's actually useful. Let's see, let's look through here. There's country. This is not a stop word. American is not a stop word. American. Trump are the, when I look at the top 10 terms in each of my topics, so clearly when I try to remove the stop words, and I tried 3 different ways. Remember, I removed from using the TM remove stop words with English, Smart, and then I used the QDAPS dictionary top 200. So clearly something didn't work out. I would go through and fix it. But I thought about it, and I feel like this is a good thing to point out when things do not go right. How would I go back and fix this? I would have to go back and somehow figure out how to get those words to be removed. It worked in my code, which is posted on Canvas, but it didn't work inside R Markdown. So I'm pretty sure we're going to get crap topics from here on out. But yeah, let's run with it. So after I get my topic, my LDA model built, I can see what are the top terms in each of them. And so I use within the topic models package terms, and then the number of terms that I want, and I can see how many there are in each of them. Now another thing I can look at is I can use the posterior function. So here we've got the prior distribution is the uninformative uniform distribution. The posterior is what we get from the model using the Dirichlet distribution. And we can see, like how much each of the word contributed to each of these. And we can see, so this gives us like the weight of each word in each topic. And this is how the major terms are figured out. So for topic 1, these numbers along this row determines how much each term contributed to topic 1. And so if I was to go through and sort all these words by these numbers, the ones that with the biggest would be the and you. Now here, DemDub refers to the Democratic debates. And so, you can look through and see it. I don't find this very informative, but it is useful if you are going to be interested in it. If you want to convert the weight, if you want to look at all the terms in relation to a particular topic, you can pull those out. So something that might be interesting would be what are the least, which words have the least weight in a particular topic. All right, so now when we look at the posterior from our model, if I take the posterior and I take the topics, it will give me the 5. So I've got 5 topics, so it'll give me 5 columns, and for I've got the equal number of rows as I have for my document term matrix. All right, this is what we could use for our dimension reduction if we want to. Now, honestly, looking at this, all these numbers are between 0 and 1. You'll notice that these add up to 1. Now, remember, I have a whole bunch of stop words in there. My model is crap, and all these numbers are really close to 0.2, 1/5. All right, so this is crap output. Honestly, my home computer isn't strong enough to run topic analysis. I'd have to go back to work, get my better computer, and with coronavirus going on, I'm just going to stay put as is. All right, so now let's say I wanted to accept this model. Now I could use these straight out, these vectors, but if everything is between 0 and 1, the numbers tend to be kind of close to each other. One thing you might want to consider is transforming this with the log of the likelihood or the log odds. So when I say odds, that's p divided by 1 minus p, and then take natural log of that. Or another one might be the odds, that's p divided by 1 minus p. And so then that gives us a way of kind of spreading out these numbers. And the extreme values there's a lot more separation between our extreme values when we do that. So the values close to 0 and close to 1 really get spread out. But in those cases, you want to make sure that you don't have any actual zeros or ones, depending on which transformation you choose. Now I went ahead and took a look at the correlation between my topics. So this is another point that's where topic analysis is different from PCA. PCA, remember, we have 0 correlation. The vectors are perpendicular from each other, orthogonal, when I do PCA. Here, when I do topic analysis, that's not the case. They're not purely uncorrelated with each other. We can see, if I look here, I've got what, a 0.44. I mean, there are plenty of psychology papers that have reported a 0.44 correlation. So that's something to be mindful of. Now, another thing we can do, if I want to look at the terms, instead of just saying top 10, I can set a threshold where I want to see all of the terms that have at least this big of a term value in it. And then it'll spit that out for me. And that comes from this matrix here. So for each topic, each of the rows here, I'm just picking up the columns, the terms that have at least this value. All right, so something that we need to consider, how many topics should we use? Now, something to remember when you do this is that the model will change depending on the number of topics we choose. This is different from PCA. So if I want in the topics model, or the topics model packages, there is a likelihood and a perplexity measurements for our LDAs. So then we can use those to kind of get a guide on what we should do. I personally think perplexity is the better way to go for this, but log likelihood is definitely a reasonable one. That's based off the maximum likelihood estimate. Now, there are 2 different ways to compute our LDA model. There's one that's the more standard way, and one that uses Gibbs sampling. If I use Gibbs sampling, I cannot use perplexity. So that's something to be mindful of. When I was playing around, I was doing some benchmarking, I found that the Gibbs sampling was a lot faster when I had a lot of topics, and it was slower when I had very few topics. So that's something to be mindful of when you choose how to execute. And we determine that by using the method parameter inside the LDA function. All right, so if I run the log likelihood of our 5-topic model, I get that. That's not very big. And if I take the perplexity, it's going to be, around 41. All right, so now what I wanted to do was go through and actually compute a bunch of different LDA models with the number of topics going from 2 to 20. The minimum number of topics is 2, because if I had just one topic, that would be the entire document term matrix. Doesn't make any sense, not informative, so we're skipping that one. So then here I go through, I compute the LDA with the number of topics being set from 2 to 20, and then I take the log likelihood, and you'll notice that I keep on using the lapply and sapply functions to make this fast and quick. Lapply always gives you a list output. Sapply attempts to simplify the output for you if R can figure out how to do that. Alright, so when I look at this, remember when we talk about likelihood, remember like we talk about maximum likelihood estimates, I want to maximize my likelihood. That's how I want to choose my model for this one. For this one, we can see that the minimum number is the best one. So here it's 2. Remember, also my stop words were not removed. I have crap topics in this situation, but we've got output to talk about and to look at. Now here I want to run the perplexity, and I'm using the sapply function once again. Oh, and when I do this step here, computing all the LDAs, that does take a while. It took some time, but everything after that was quick and easy, lemon squeezy. Alright, here when I look at perplexity, once again, the smallest number of topics is the best one. Remember, I have crap model or crap topics because of stop words. And so then here, either way, I would conclude that I would use that 2 topics would be the best course of action. Really, what I would want to do, I would want to go back, make sure that all my stop words are removed, and then execute this again. If I see like a bump, where the bump goes low in my perplexity, that's where I want to use, or that's the one I want to use for my number of topics. That is all I've got. Thank you so much. Please stay healthy.